In 2018, an excavation carried out in the frozen soils of Siberia uncovered a tragic scene that had remained hidden for thousands of years. The dig site was located near the Altai Mountains, in the vicinity of the Denisova Cave, a crossroads where some of the oldest human lineages and extinct megafauna once overlapped. But this time, the discovery was not a few bone fragments or isolated teeth. Hundreds of fossil remains belonging to different species were found together in the same layer. The structure of the layer was intact. Bones, skins, and traces of fur embedded in sedimentary rocks were preserved as if time had suddenly stopped. At first glance, the excavation team encountered familiar shapes. The curved tusks of mammoths were immediately recognizable. Within the same stratum, they also unearthed giant antlered deer skulls, vertebrae of massive herbivores, and the remains of clawed predators. Different life forms were interwoven within the same sediment on the same horizontal plane. The initial assumption of scientists was that this was a mass death scene, perhaps the result of a sudden mudslide or rapid freezing. However, detailed analyses suggest the event was far more complex than a simple natural disaster. The fossil-bearing sediment layers were covered by a brief but intense accumulation of mud, likely triggered by a sudden temperature spike. This indicates that the animals may have died almost simultaneously, been buried quickly, and then preserved in remarkable detail by an abrupt freeze, so fast that even tissue structures and organ imprints may have been retained. So what exactly happened 10,000 years ago? To better understand this, we need to look back at the world of 10,000 years ago. At that time, Earth was going through a transitional phase, marking the final stage of the Ice Age. The atmosphere was drier, temperatures were lower, and much of the year was marked by frost. Despite these harsh climate conditions, the planet was teeming with massive life forms. And these giants didn't live in ordinary habitats. They thrived within a vast and unique ecosystem known today as the Mammoth Steppe. The Mammoth Steppe was a colossal land belt. It stretched from the endless tundras of Siberia across the northern plains of Europe all the way to the cold expanses of Alaska and Canada. Throughout the Ice Age, this region served as a buffer zone between the southern edge of the polar ice sheets and the milder areas farther south. It was neither fully frozen nor completely thawed. The terrain featured short summers, long winters, and dry soils sculpted by relentless winds. In these regions, cold-adapted grasses and low shrubs dominated. There were no trees, no forests. The sun would rise for only a brief period each day, but that limited light was still enough for photosynthesis. Though sparse in appearance, the vegetation was nutrient-rich. For millions of herbivores, this meant a continuous cycle of survival. Mammoths, bison, reindeer, woolly rhinoceroses, and giant ground sloths were the most familiar faces of these grazing lands. Following them were lions, wolves, saber-toothed cats, and jackals, the predators of this same cycle. And among the most iconic creatures of this lost world were, without a doubt, the mammoths. An average adult woolly mammoth could stand up to 13 feet tall and weigh nearly 13,000 pounds. But size varied significantly across species. One of the largest, the imperial mammoth, was almost twice the size of a modern African elephant. On the other hand, dwarf species that lived on islands were no bigger than a standard car. This diversity reflects how mammoth species adapted to different environments. Their most distinctive feature was their dense, double-layered fur. The underlayer consisted of fine, insulating hairs, while the outer layer was made of thick, wavy strands. This structure allowed them to maintain a stable body temperature even in conditions as cold as -60 degrees Fahrenheit. Their long, curved tusks were not just tools for defense. They were used to dig through snow to reach grass, to compete with rivals, and to establish social order within the herd. The spiral shape of the tusks is still used today to determine a mammoth's age and species. Mammoths did not live in isolation. They were social animals, living in large herds with complex group dynamics. Female mammoths would form small groups with their young, while males typically left the herd after adolescence to live more solitary lives. Their diet mainly consisted of dry grasses, low shrubs, and frozen roots. Yet even with these limited resources, a single mammoth could consume up to 400 pounds of food per day. This meant their habitats had to be constantly traversed and foraged to support their enormous appetites. But the northern forests and open plains of the Ice Age weren't just home to massive herbivores. Sharing that same land was another giant, the cave lion, closely related to today's African lions, but far more imposing. Skeletal measurements show that these animals were 20 to 25% larger than modern lions. Their shoulder height reached 4 feet, and they could weigh up to 700 to 70 pounds, making them one of the largest terrestrial predators of their time. But it wasn't just their size that set them apart. Unlike modern lions, most male cave lions didn't have manes. Instead, they had thicker neck muscles and short, dense fur that helped cut through the wind. These features allowed them to move more efficiently across the frozen grasslands of Siberia and Europe. Their coats would grow thicker with the seasons, helping them retain body heat. In other words, the cold had reshaped their form. Their hunting strategy was also unexpected. They didn't always operate alone, but often moved in organized groups. Fossil traces, cave paintings, and remains of hunting scenes offer clues. For example, at Chauvet Cave in France, wall drawings dated to around 30,000 years ago show multiple lions facing the same direction. These images suggest that cave lions hunted cooperatively and may have targeted large prey, including young mammoths. The archaeological record doesn't stop at cave walls. Bones and claw marks found in various European caves reveal close encounters with humans. In some sites, tracks from both humans and lions are found impressed into the same layers of sediment. This shows that cave lions weren't just part of nature. They were direct witnesses to prehistoric human life. The cave lion had a vast range across Eurasia. From the Iberian Peninsula in the west to deep into Siberia in the east, they thrived in the cold, open landscapes of the Ice Age. Their muscular build and long-distance mobility suited this terrain perfectly, but even this wide range could not protect them forever. Cave lions were strong and imposing, but they weren't the only predators roaming those lands. There was another kind of hunter, one that relied not on brute force, but on technique. Silent, composed, and precise. A predator that struck like a shadow and ended everything within seconds. Smilodon, commonly known as the saber-toothed tiger. At first glance, it's the teeth that draw all attention. The 8-inch-long, dagger-like fangs hanging from its upper jaw pushed the boundaries of what seemed possible in an animal's mouth. But Smilodon was strange, not just because of its teeth. Its entire body was unusual. Thick forelimbs, low and muscular shoulders, short but powerfully built hind legs. This animal didn't resemble a typical cat or any familiar predator. Smilodon was never built for speed. It moved slowly and deliberately. Its muscles were designed to deliver maximum force in short bursts. That's why its primary targets were large animals, young mammoths, giant ground sloths, or massive deer. Paleontologists believe Smilodon would first knock its prey to the ground, then drive its saber teeth into the neck or throat, piercing major blood vessels directly. This wasn't the classic kill by claw swipes. It was controlled and targeted. Death didn't come in minutes. It came in seconds. Yes, Smilodon's teeth were incredibly long and sharp, but they were also extremely fragile. A poorly aimed strike could cause them to crack or even break. So if it missed its mark, Smilodon's greatest weapon could become its greatest vulnerability. One of the most important clues helping us understand these details comes from the La Brea tar pits in California. These natural asphalt traps ensnared thousands of animals over thousands of years. But among the most frequent finds are the remains of Smilodons, hundreds of them. And many of these skeletons show signs of healed fractures, fused bones, and past injuries that had been survived. This suggests that Smilodon may not have been a completely solitary animal. It might have displayed group behavior at times, possibly sharing prey or even supporting injured members of its kind. Standing against these deadly predators were giants that had developed their own strategies for defense. Megatherium, the giant ground sloth. Despite the name, it had almost nothing in common with today's tree-dwelling sloths. Megatherium was like a walking fortress, reaching up to 20 feet in height and weighing more than 9,000 pounds. Bringing it down wasn't something just any predator could attempt. One of its greatest advantages was the ability to rise up on 2 legs. This wasn't just useful for grabbing leaves from tall trees, it also allowed the animal to shift into a defensive stance. When standing upright, its forelimbs revealed massive claws, up to a foot long. These claws weren't just for stripping bark, they were also formidable weapons in a fight. So Megatherium wasn't a helpless giant, it was a potentially deadly force in its own right. Its feeding habits meant it had to stay in constant contact with its environment to meet its enormous energy needs. A typical Megatherium consumed around 400 pounds of leaves per day. That required roaming through wide forested areas, always in search of foliage, and always at risk of encountering danger. But being big doesn't always mean being safe. Its massive body provided protection, but also slowed it down. In case of an attack, it needed time to assume a defensive posture. And if the predator struck first, even a single opening could prove fatal. Especially when facing something like Smilodon, which targeted vital arteries with surgical precision, Megatherium's only hope was early detection and immediate resistance. Fossil evidence shows just how delicate this balance was. Some Megatherium skeletons bear the marks of conflict. Bite wounds in the shoulder region, broken ribs, and healed claw scars. This tells us it was attacked more than once, but often survived. So Megatherium wasn't just large, it was resilient. While the giant ground sloths relied on their powerful claws for defense, some animals chose to use their beauty as a weapon. The Irish elk. Its antlers extended sideways with a span of up to 11.5 feet, slicing through the air with every movement of its head. But that magnificence came at a cost. These structures, weighing nearly 90 pounds, were shed and regrown every year. To support this process, the elk's body had to invest an extraordinary amount of calcium and energy. Males carried these massive antlers to intimidate rivals and attract the attention of females. In other words, this beauty served as a declaration of competition. But nature works by different rules. Outside the mating season, these antlers became a burden. They made it harder to move through forests, limited quick escapes, and rendered the animal nearly defenseless against predators. Especially as glaciers began to retreat and forests spread, the woodland canopy became a deadly trap for Irish elks. As trees grew denser, maneuvering with such enormous antlers became nearly impossible. At that point, natural selection began to work in reverse. Beauty stopped being an advantage and turned into a cause of death. The antlers still grew, still fell off, but they no longer served survival. On the contrary, they made the elk more fragile and more vulnerable. The fossil record clearly reveals this contradiction. In many of the final Irish elk specimens, abnormalities in antler development have been observed. In some individuals, the antlers never fully formed. In others, they extended excessively to one side. This suggests that the species disappeared too quickly to genetically adapt to increasing environmental pressure. The story of all these magnificent creatures converges around the same question: why did they all disappear? The answer to that question requires looking not just at one species, but at an entire ecosystem. Around 12,000 years ago, Earth's climate system entered an irreversible phase of change. The Ice Age was ending, and average temperatures began to rise, slowly but steadily. The first thing to change was the soil. As the glaciers retreated, the cold weather grasses and tundra plants gave way to flowering plants of warmer, more humid climates. On the surface, this shift may seem simple, but for herbivores, it had deadly consequences. That's because mammoths, giant ground sloths, and Irish elks had spent thousands of years evolving to feed on very specific types of vegetation. The new plant life didn't suit their digestive systems. The problem wasn't just hunger, it was encountering food their bodies didn't recognize. And this change didn't only affect the herbivores, it impacted every species that depended on them. As herbivores weakened, predators began to struggle to find food. Apex hunters like cave lions and saber-toothed cats vanished one by one as the number of healthy prey dwindled. Every link in the chain depended on the one before it, and those links were breaking fast. To make matters worse, one unnatural factor entered this natural cycle: humans. By that time, Homo sapiens had spread across every continent on Earth. Their tools were becoming more effective, and their hunting methods more coordinated. Big animals meant more meat, more hide, more bone. That made them more frequent targets. Some studies suggest that climate change alone wasn't enough. In places where humans entered the scene, extinction rates appear to have sharply accelerated. In other words, the initial weakening came from environmental changes, and humans delivered the final blow. But here's the interesting part. Some species held on longer than others. Starting with Europe, the cave lion was among the first to vanish. It's estimated that the last individuals lived around 12,000 years ago. Most likely, they couldn't withstand the pressure of hunting in the Iberian Peninsula or Eastern Europe. Next came the saber-toothed cats in North America. They disappeared around 10,000 years ago. Their powerful jaws and saber teeth were useless once prey became too scarce. As we move into South America, the giant ground sloths managed to hang on a bit longer. Fossils dated to about 8,000 years ago suggest they had adapted to warmer, more forested environments. Irish elks took their final breath in the lands that gave them their name. Their massive antlers became deadly when combined with rising temperatures. The last fossil evidence dates back to around 7,700 years ago. But the most fascinating chapter in this story belongs to the mammoths. Mainland mammoths disappeared around 10,000 years ago, just like the rest of the megafauna. But on a tiny patch of land near the Arctic Circle, Wrangel Island, a small population of much smaller mammoths continued to survive for thousands of years. It's believed the last individuals lived until about 4,000 years ago. In other words, while the pyramids of Egypt were being built, there was still a living mammoth somewhere on Earth. So why did some species survive while these giants didn't? Today, polar bears, bison, deer, and hyenas still exist. Was the key difference simply body size? Or did evolutionary adaptability, genetic diversity, or perhaps just pure luck play a bigger role? All of these questions remain unanswered. What do you think led to their extinction? Let us know in the comments, and we'll see you in the next video.